Hello viewers, I extend a hearty welcome to all of you in this new series of our discussion on the salt analysis. Up till now, we have studied the preliminary tests. We actually continued with this discussion, and I chose first the acid radicals. In case of acid radicals, we first of all performed a preliminary test, that is dilute H2SO4 test, and then some radicals which are indicated or we get an indication about their presence in dilute H2SO4 test, then we confirmed these radicals. These radicals are namely carbonate, bicarbonate, sulfide, sulphite, then thiosulphate and nitrite. I repeat always in all the lectures that since this is a very basic and preliminary discussion, because aim is that it should go well with all those students who have a phobia about salt analysis, and they should understand these things. So I am keeping the things simple. Now after that, after confirming the acid radicals detected with dilute H2SO4, then we performed KMnO4 test, which also gave us some indication regarding some acid radicals, which were subsequently confirmed with concentrated H2SO4 test, and some cations also. And then in the following lectures, we discussed concentrated H2SO4 test as a preliminary test, and the radicals which were indicated with concentrated H2SO4 test, we confirmed those radicals by the confirmatory tests. These radicals included chloride, bromide, iodide, nitrate, acetate, oxalate. Here also I omitted tartrate and some other radicals which are at the advanced stage. So I kept it up to say preliminary level. Now, sometimes what happens that some acid radicals are present in the given mixture, but they are neither indicated with dilute H2SO4 nor with concentrated H2SO4 tests. And in our simple language, we label them as individual radicals. These radicals include, we have got sulphate. This is sulphate. Then we have got phosphate. Then borate, then arsenite, arsenate, and chromate, that is CrO4 2 negative. Again, in this case also, I shall be discussing with you only these three radicals. Why? That these radicals, arsenite, arsenate and chromate, they are not very common. So today's discussion will be limited over these radicals. Dear viewers, for the sake of easy understanding of the subject of the discussion on sulphate, phosphate and borate radicals, I have divided it into two parts. In the first part of the discussion, in this lecture, I'll be taking up the chemistry underlying the discussion of the sulphate radical only. Okay. Now, first of all, we come over to sulphate. The tests performed are, number one, that is barium chloride test. What we do is, most of the sulfates are soluble in water. However, sulfates of mercury, lead, barium, strontium, etc., they are not soluble. But since we are not dealing with single salt, we are dealing with a mixture of salts. So we can take salt, we can take water solution if the salt is soluble, or water extract or soda extract. So as to eliminate all the possibility of errors, we take soda extract, and soda extract is acidified with dilute HCl. Then some carbonates, etc., if they are present, then they are decomposed, and then that is decomposed with dilute HCl, and then we add barium chloride solution in water into it, and we get white precipitate. So what is the chemistry behind? Let us say we have got sodium sulfate. We add barium chloride into it. Double displacement takes place. We get barium sulfate plus 2 sodium chloride, and this is a white precipitate. If you remember, we performed this barium chloride test earlier also. We performed this test in case of sulphite, but the difference was that barium sulfite formed here was soluble in dilute HCl. Whereas in this case, the barium sulfate precipitate, it is not soluble in dilute HCl. So our test is that neutralized soda extract, we add dilute HCl to neutralize it, and then we add barium chloride, and white precipitate persists, indicating thereby that sulfate is present. Now, second test for this is that is lead acetate test. In this case, again, what we do is we neutralize or decompose the soda extract with acetic acid, followed by the addition of lead acetate, and again we get the formation of white precipitate. How? We have got, say, sodium sulfate. This was in soda extract. Then we add to it lead acetate. We get the formation of lead sulfate, plus of course 2 molecules of CH3COONA, and again this lead sulfate is a white precipitate. So these are 2 simple tests, that is barium chloride and lead acetate. But there's another test which is very interesting test, but of course a little difficult to perform also. That test is known as matchstick test. What this test is? We prepare white precipitate with barium chloride as we did in the test number 1, and that white precipitate is mixed with almost same or maybe more than that, say double amount of sodium carbonate powder. We make a paste, and we mount this paste on the end of a wooden splinter, matchstick or wooden splinter, and that wooden splinter is introduced into the Bunsen flame, reducing flame, and heated strongly in such a way that the mass fuses, and some of the wooden splinter also gets involved into it. It also gets burnt. Then this fused mass is touched to the top of sodium nitroprusside solution taken in a test tube. And if sulfate is present, we'll be getting purple streaks which are descending down from that point of touch to the bottom of the test tube, which confirms the presence of sulfate. So what is the chemistry behind? Suppose we have got, say, magnesium sulfate. We added barium chloride into it. We got the formation of barium sulfate, plus of course magnesium chloride. This barium sulfate white precipitate is mixed with sodium carbonate. double displacement takes place, we get the formation of sodium sulfate. Plus, of course, we have got sodium sulfate, and then we get barium carbonate that decomposes. So you may get this. This is sodium sulfate plus barium carbonate. And then this barium sulfate, this sodium sulfate now mounted on the edge of a wooden splinter, and splinter is burnt. Carbon of the wooden splinter comes in contact with this and reduces this sulfate into sulfide. So we get the formation of Na2S, plus of course we'll get 4 carbon monoxide. I'm not balancing it. If you want to balance, then we can have 4 here. Now this sodium sulfide thus formed is touched with sodium nitroprusside solution, which is Na2Fe CN5NO, and we get the formation of Na4Fe CN5NOS. This is sodium thionitroprusside, and this has got purple color. Again, I want to remind you that this test we performed as a confirmatory test for sulfide also. So here also we are doing the same thing. We had got a sulfate, we converted it to barium sulfate, then this barium sulfate is mixed with sodium carbonate, the mass is heated strongly, fused, and then double displacement takes place, we get the formation of sodium sulfate, and then that sodium sulfate comes in contact with the carbon part of the wooden splinter, and then of course the reaction takes place and this sulfate gets reduced to sulfide, and that part of the wooden splinter, fused mass, when we touch this with sodium nitroprusside, then sodium nitroprusside comes in contact with this, we get the formation of sodium thionitroprusside, which has got a purple color. So this is mestric test. As I told you that usually students or maybe teachers, they are not they cannot fuse the mass properly, and unless the mass is fused and the carbon comes in contact with sodium sulfate, this test will not happen. So that's why I said that this is a very interesting test but a little difficult.